Hello, my name is Shiv Sinha and today we will learn about the circular queue. So in the previous video we have learned about the queue and its types. So in this video we will learn about the types of queue in a more detailed manner. So why was the concept of the circular queue introduced? There was one limitation in the array implementation of the queue. If the rear reaches to the end position of the queue, then there might be possibility that some vacant spaces are left in the beginning, which cannot be utilized. So, to overcome such limitations, the concept of the circular queue was introduced. So, as we can see in the image, the rear is at the last position of the queue and front is pointing somewhere rather than the zeroth position. In the above array, there are only two elements and other three positions are empty. The rear is at the last position of the queue. If we try to insert the element, then it will show that there are no empty spaces in the queue. There is one solution to avoid such wastage of memory space by shifting both the elements at the left and adjust the front and rear edge accordingly. It is not a practically good approach because shifting all the elements will consume lots of time. The efficient approach to avoid the wastage of the memory is to use the circular queue data structure. So what is a circular queue? A circular queue is similar to a linear queue as it is also based on the FIFO, first in first out principle, except that the last position is connected to the first position in a circular queue which forms a circle. It is also known as ring buffer. So what are the operations of circular queue? The following are the operations that can be performed on a circular queue. First is front. It is used to get the front element from the queue. The second is rear. It is used to get the rear element from the queue. The third is enqueue. The function is used to insert the new value in the queue. The new element is always inserted from the rear end. Then comes the dequeue. This function deletes an element from the queue. The deletion in a queue always takes place from the front end. Then comes the application of circular queue. Right. So the circular queue can be used in the following scenarios. First is the memory management. The circular queue provides memory management. As we have already seen that in linear queue the memory is not managed very efficiently. But in case of a circular queue, the memory is managed efficiently by placing the elements in a location which is unused. Then comes the CPU scheduling. So the operation system also uses the circular queue to insert the processes and then execute them. Then comes the traffic system. So in a completed control traffic system, traffic light is one of the best examples of the circular queue. Each light of the traffic light gets on one by one after a fixed interval of time. Like red light gets on for 1 minute, then yellow light for 1 minute, and then green light. After green light, the red light gets on. So if we talk about the enqueue operation, so the steps of enqueue operations are: first we will check whether the queue is full or not. Then initially the front and rear are set to -1. After that, when we insert the first element in a queue, front and rear both are set to be 0. So when we insert a new element, the rear gets incremented, that is rear equals to rear plus 1. So if we talk about that, if rear equals to, or sorry, not equals to, right, rear not equals to max -1, which means that the rear will be incremented to mod max size and the new value will be inserted at the rear end of the queue. Similarly, if the front, right, not equals to 0 and rear equals to x minus 1, which means that q is not full. Then set the value of rear to 0 and insert the new element there, right? So these are the two scenarios in which q is not full. So again, there are, let me show you guys, there are two cases in which the element cannot be inserted. First, when front equals to 0 and rear equals to x minus 1, right? So it means that the front is at the first position of the queue and rear is at the last position of the queue. Again, another operation is that front equals to rear plus 1, right? Which means that these the two operations when front equals to 0 and rear equals to max minus 1 and front equals to rear plus 1, these are the two cases in which elements cannot be inserted, right? So let's go. Now we will see about the DQ operation, right? DQ. So we have learned the circular queue and we will learn about the DQ. So before going to the DQ, we should see a brief description of the queue first. So what is a queue? A queue is a data structure in which whatever comes first will go out first, and it follows the FIFO policy, first in, first out. Insertion in the queue is done from one end, known as the rear end or the tail, whereas the deletion is done from another end, known as the front end or the AW. The real world example of a queue is the ticket outside a cinema hall, where the person who enters first in the queue gets the ticket first, and the person enters last in the queue gets the ticket at last. So coming to the what is a DQ or double-ended queue? The DQ stands for double-ended queue. As we know, DQ is a linear data structure where the insertion and deletion operations are performed from both ends. We can say that DQ is a generalized version of the queue. Though insertion and deletions in a DQ can be performed on both ends, it does not follow the FIFO rule. The representation of the DQ is given as follows, right? This is a representation of DQ, the insertion, removal and removal. These the four operations, or we can say the two operations actually, insertion and removal, are occurring at both the front end and the rear end. So there are two types of DQ, input restricted queue and output restricted queue, right? So in the previous video I have explained these two, so let me again explain for you guys so that you can understand. It is not so much complicated. So what is the input restricted queue? In here we can see that insert will be occurred only at the front end and deletion will be occurred at both the front and rear end. So that is why it is called the input restricted queue, because input is only occurred at the front part. So you can see that insertion operations can be performed at only one end, while deletions can be performed from both ends. Similarly, in case of output restricted queue, we can see that insertion occurs on the both ends, that is front and the rear, and the delete operation only occurs at the rear end. So that is why it is known as the delete restricted queue or the output deletion of restricted queue or the output restricted queue. So basically there are some following operations which can be applied on a DQ. First is insertion at front. The second is insertion at rear. The third one is deletion at front. The fourth one is deletion at rear. So we can also perform peak operations in the DQ along with the operations listed above. Through peak operations we can create the DQ's front and rear elements of the DQ. So in addition to the above operations, following These are the some operations which are supported in DQ. Get the prod item from the DQ, get the rear item from the DQ, check whether the DQ is full or not, and check whether the DQ is empty or not. Now let's understand the operations performed on DQ using an example. First will be the insertion at the front end. So in the operation, the element is inserted from the front end of the queue. Before implementing the operation, we first have to check whether the queue is full or not. If the queue is not full, then the element can be inserted from the front end as respectively. Then the insertion at the rear end case, in this case of operation, the element is inserted from the rear end of the queue. So we first have to check again whether the queue is full or not before implementing the operation. If the queue is not full, then the element can be inserted from the rear end as well. Then comes the deletion at the front end. In this operation, the element is deleted from the front end of the queue, and before implementing the operation, we first have to check whether the queue is empty or not. If the queue is empty, that is front equals to -1, it is the underflow condition and we cannot perform the deletion. If the queue is not full, then the element can be inserted from the front end by using the conditions, right? And finally, deletion at the rear end. In this operation, the element is deleted from the rear end of the queue. Before implementing the operation, we first have to check whether the queue is empty or not. If the queue is empty, that is front equals to -1, it is the underflow condition and we cannot perform the deletion. If the DQ has only one element, set rear equals to -1 and front equals to -1. If rear equals to 0, rear is at front, then set rear equals to n-1, else decrement the rear by 4. And finally comes the applications of DQ. So DQ can be used as both stack and queue as it supports both operations. Then the DQ can be used as a palindrome checker, means that if we read the string from both ends, the string would be the string. For example, if I give you an example of 1 to 1, so you guys can observe carefully that 1 to 1 will be a palindrome because the number will be the same from both the ends, that is front and the rear. So now comes the final part, the final queue, that is priority queue. So what is a priority queue? A priority queue is an abstract data type that behaves similarly to the normal queue, except that each element has some priority. That is, the element with the highest priority would come first in a priority queue. The priority of the elements in a priority queue will determine the order in which elements are removed from the priority queue. The priority queue supports only comparable elements, which means that the elements are either arranged in an ascending or descending order. For example, suppose we have some values like 1, 3, 4, 8, 14, 22, right? So, let's come to the notepad. So, there are three numbers, 1, 3, 4, 8, 14, and 22. These are some random numbers which I have taken. So these random numbers are inserted in a priority queue with an ordering imposed on the values, that is from the least to the greatest. Therefore, the number 1, because of its least value, will be having the highest priority, while 22 having the lowest priority because of its highest value, right? So we can say that the characteristics of priority queue are: a priority queue is an extension of the queue that contains the following characteristics. Every element in a priority queue has some priority associated with it. The second one is an element with the higher priority will be deleted before the deletions of the lesser priority. So, as we can see as we have seen in the notepad, that the number, because the 22 will be deleted first because of its higher priority. The higher priority, the number will be deleted before the deletion of the lesser priority. So, as as you can see that the number 22 will be deleted at first because of its highest value, and the number will be deleted at the very end because of its lowest value. So these are some characteristics. So the characteristic is, if two elements in a priority queue have the same priority, they will be arranged using the FIFO principle. If I take this number at 1, 3, 4, 8, 14, 22, we will see that all the values are arranged in a ascending order. So we will observe now that how the priority queue will look after performing the following operations. First one is poll operations. So this function will remove the highest priority element from the priority queue. In the above priority queue, the one element has the highest priority, so it will be removed from the priority queue. Suppose one has the highest priority, so it will be removed, right? Again, the add operation. This function will insert two elements in the priority queue. S2 is the smallest element among all the numbers, so it will obtain the highest priority. Again, the poll function, if I perform, then it will remove the two elements from the priority queue as it has the highest priority queue, right? So again, if I add a 5, it will insert 5 elements after 4, right? So as 5 is larger than 4 and lesser than 8, so in here 5 number will be added, so it will obtain the third highest priority of the priority queue. Now the types of priority queue. First one is ascending or order priority queue. In ascending order priority queue, a lower priority number is given as a higher priority in a priority. For example, we take the numbers from 1 to 5 arranged in an ascending order, like 1, 2, 3, 4, 5. Therefore, the smallest number, that is 1, is given as the highest priority in a priority queue, right? So if we see this example, the 2, 6, 7, 10, 11, the two elements will be the highest priority because it has the lower priority number, right? And the element 11 with the lowest priority because it is a higher priority number, because its value is 11 and it is much more than 2, right? So again, in case of descending order priority queue, in descending order priority queue, a higher priority number is given as a higher priority in a priority. For example, we take the numbers from 1 to 5 arranged in descending orders, like 5, 4, 3, 2, 1. Therefore, the largest number, that is 5, is given as the highest priority in a priority queue. So if we see the 10, 9, 8, 7, 6, the element with the highest priority will be 10 and the element with the lowest priority will be 6. Now, coming to the application part, we can say that there are some basic applications which we have performed during the priority queue operations. For example, first of all, the first one application is that it is used in Dijikr's shortest path algorithm. We will learn that algorithm later, right? So the second one is it is used in Prim's algorithm. The third one is that it is used in data compression techniques like Huffman code. And the fourth one is it is used in also heap sort. Then final application will be it is also used in operating system like priority scheduling, load balance and interrupt handling. So these are all the types of queues within a much more broader way. In case if you guys don't want to understand the concept in a full detailed manner, then you can watch the previous video which I have uploaded already, that is the queue and the types of queue. So in that video I have also explained the types of queue but in a more short manner. So this will be helpful if you guys want to learn in a more thorough way, right? So in the after video, in the next video we will learn about the most important topic of data structure, will be the DSC. So till then, bye bye.